Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth.
Hello everyone, and welcome back to Physics with Beth and Beth. I'm Beth, and in this video we are continuing our discussion of Unit 1 of our calculus-based physics curriculum. So in this video we're going to be practicing finding the angle between two different vectors. So best place to begin is at the beginning, so let's go. Here we have our problem. We're asked to find the angle between these two different unit vectors, or vectors that are written with our unit vector form. We've got vector A, that's 3i hat plus 4j hat, and vector B, that's 5i hat plus 12j hat. So if I've drawn these two out here on this extremely not to scale graph, but we've got a little sketch here of vector A, so we go over 3 in the x direction and 4 in the y or j hat direction. And vector B is similar with 5 and 12. And we're trying to find this angle here, that difference between the angle of vector A and the angle of vector B. Now there are two different ways we can go about solving this. One is with our good old friend SOHCAHTOA, and the other is by using the dot product. My fellow Beth and I personally think that the first way, using SOHCAHTOA, is a little easier for this problem. So we're going to walk you how to solve this problem using that method first. But because it's always useful to have a couple different tools in your pocket and getting some practice with the dot product is a good idea, then we're going to go into that second way in the second half of this video. So let's get started. Well, if we want to find the difference between these two vectors, well then first we need to find the angle of vector B. We can use that using SOHCAHTOA, which becomes a little easier to see if I sketch this out. So this is vector B, it's pointed like this. He's got a y or j hat component of 12 and an x or I hat component of 5. And we're trying to find this angle here. So we can do that. Well, side 12 here is our opposite of our angle, and our 5 length side here is the adjacent side to our angle. So we can just use tangent, or inverse tangent rather, of our opposite over our adjacent in order to get that angle. And if you plug that into your calculator, we end up finding that that angle here, theta B, is 67.3 degrees. Now, a good habit to get into in physics is to stop, pause, and say, does this number even remotely make sense before I keep going? Here we know that we have a much larger y component than x, so our angle should be pointing more up than it's pointing over, but not that much more up. So we're looking for a number that it is a bit bigger than 45 degrees, but isn't like almost 90. And 67 degrees fits that bill. So that makes sense. So now we can keep going. Let's do the same thing for vector A. We can just sketch out a little triangle here, and I'm going to do this up in this top corner so I don't run out of room. We have an x component of 3, a y component or j hat component of 4. We can do the same thing here. Take inverse tangent of our opposite over adjacent sides. So 4 over 3 to solve for angle A. If you plug that in your calculator, you end up finding that theta A is equal to 53 degrees, 53.13 degrees. And again, we need to pause and ask ourselves, does that number make sense? Well, 3 and 4 are two numbers that are pretty close together, so we're looking for a number that's a little bit more than 45 degrees, because we are going a little bit more up than over, but is still relatively close to 45 degrees. 53 fits that bill, so we're good there. Now, all we have to do is find the difference between those two angles. So we can just plug those into our little setup equation here. The difference between theta B and theta A is just 67.3 minus 53.13 degrees. And so that, if we plug those into our calculator, because I'm not going to try and do subtraction in my head, is 14.3 degrees. And so that is just our solution for the angle between our two vectors. And there we go. That's all there is to it. Just using a little bit of one of those little inverse trig functions in our good old friend SOHCAHTOA lets us get to that without too much difficulty. However, that's not the only way we can solve this problem. We can also give this a try using the dot product. So the dot product of two vectors is a very useful tool. So if I take the dot product of these two vectors, we know that that is equal to the magnitude of my first vector times the magnitude of my second vector times the cosine of the angle between my two vectors. This is just a fundamental property of the dot product, and it's one that we can exploit in order to get to where we want to go. So if I divide both sides of my little equation here by the product of my two magnitudes, then we end up finding, and I'm going to rewrite this, that cosine of the angle between my two vectors is equal to the dot product of my two vectors divided by the product of the magnitudes of my two vectors. So before we can go on to the next step, we need to find what the magnitudes of our two vectors are. Well, how do we do that? Thankfully, it's not too hard. This is just our good old friend, the Pythagorean theorem. So if we just Pythag these two guys, well, if we want to find the magnitude of vector b here, well, that's just a squared plus b squared equals c squared. So we're just going to take the square root of the sum of these two products. The sum of these two squares. So 5 squared plus 12 squared. If you calculate that, you should get exactly 13. This is a common pattern that you'll start seeing more and more the farther you go on in math and physics. 5, 12, 13 triangles show up a fair bit. So we get a nice pretty number there for our magnitude. And then for the magnitude of vector A, we do the same thing. We have 3 and 4, the square root of the sum of the squares is going to give us this magnitude. And this is just a 3, 4, 5 triangle. 3 squared is 9, 4 squared is 16. Those sum together is 25. You take the square root of that and you get 5. So that's another guy that shows up pretty often. So you'll start to pick up on those patterns the farther along you go in math. So now we just have to plug those guys in to our little equation over here. To find the dot product of our two vectors, you just take the I components, you take the product of your two I components of your two vectors and add that to the product of your j components of your vectors. So the dot product of A and B would just be 3 times 5 plus 4 times 12. The product of our i's plus the product of our j's. So this would be 3 times 5 plus 4 times 12. And then the product of the magnitudes of our two vectors would just be 13 times 5. So if you just do a little bit of multiplication and addition, we end up getting that those two numbers there are 63 over 65. So the cosine of our angle is equal to 63 over 65. So I'm going to just rewrite this over here. 63 over 65. And so now if we want to solve for theta, we just need to free him from the trappings of this little cosine here, which we can do by taking the inverse cosine of both sides of our equation. So theta is equal to the inverse cosine of 63 over 65. And if we plug that into our calculator, we end up finding, to our great surprise, that it is exactly the same. So this is just 14.3 degrees. And so those are two different ways that we could get to the same answer. So just to review, the first way that we did, we found the difference between our two angles by directly solving for the values of each of our angles and then taking the difference of them. So we solved for theta b by just using inverse tangent of y over x or j hat over I hat. We did the same thing for theta a and then we subtracted them to get this. Then we did that same thing and solved for that same value using instead our dot product, which directly allows you to solve for that angle without having to go through the in-between step of solving for theta A and theta B. So we did that by taking the dot product and dividing that by the product of our two magnitudes of our vectors, which we were able to find using the Pythagorean theorem, did some calculations, took an inverse cosine, and we got to exactly the same place. Neither of these ways are better than the other, and depending on your situation, one might be easier. So pick which one you're going to use based on, honestly, whichever one you like best and which seems like it would be the least amount of work based on your problem. All right, thank you so much for sticking with me through all of that, guys. If you have any comments or questions, please let us know. And we're going to be continuing to make more of these videos of AP Physics C or calculus-based physics curriculum. So if these are helping you, please remember to subscribe so that you can get updates whenever we release a new one. All right, thank you so much for sticking with me through all of that. Y'all are troopers and happy physicsing.